This lesson will focus on solving equations of different types, linear, quadratic, and especially equations involving fractions. Before you watch my solutions, please try these 5 examples on your own and then check your answers afterwards. So pause the video now and try these examples for yourself. The first example is a linear equation, so we'll group the x terms onto one side of the equation and the constant terms onto the other side of the equation. So subtracting 3x from both sides, adding 7 to both sides, and then dividing both sides by 2. The second example is a quadratic, and for me the best strategy with a quadratic is to group all the terms onto one side so that the equation equals 0. So we'll subtract 21 from both sides, and then we'll see if we can factorise this equation. Well, I know that 7 times 3 is 21, and the difference between 7 and 3 is 4. So that looks promising, and we need the two numerical parts to multiply to give negative 21, which means one is positive and one is negative, and they need to sum to negative 4. So it's take 7 and plus 3, and the reason for doing this is so we can use the null factor law. We know that if we've got a product of two expressions equaling 0, then one of them must equal 0, and therefore x is 7 or negative 3. In the third example we've got some fractions, but they all have numerical denominators. So when we're adding fractions or when we're equating fractions, we need a common denominator. In this case, 2, 6, 3 and 6 are all factors of 6, so I'll rewrite this with all denominators of 6. 2 of the terms remain the same. X over 2 is the same as 3x over 6, and 4 over 3 is the same as 8 over 6. Once we've done that, if we've got fraction expressions equaling each other and they have the same denominators, then the numerators must equate as well. You can see this as multiplying through by 6, so we can eliminate those denominators, and then we've got a simple linear equation to solve. Subtract x from both sides and subtract 1 from both sides, and then divide both sides by 2. This fourth example also contains fractions, but this time we've got algebraic expressions in the denominators. So I still want to start by writing each term with a common denominator. And this time I'm going to multiply the denominators together to get that common denominator. So 5 over 2 take x. I need to multiply the numerator by x plus 1, and 3 needs to be multiplied by both of these, and 4 to take x. So now all of my denominators are the same. I can multiply through by those denominators and the numerators will equate. At the same time I'm going to expand the brackets so that I can collect like terms afterwards. So actually I've got a quadratic here. I want to gather all the terms onto one side and make it equal to 0. So I'm going to add 3x squared to both sides, and we've got 6x, take 3x, take 4x. So I'm going to add x to both sides, and then we've got 6 plus 8, so I'm going to subtract 14 from both sides. Now each of these terms is divisible by 3, and I'm going to look to see if this will fully factorise so I can use the null factor law. 1 times 3 is 3, and 3 take 1 is 2, so plus 3 and subtract 1, and my two solutions are x is negative 3 or positive 1. Now at this point I just need to check back to my original expression to make sure that these solutions are valid. Because we've got x's in the denominators, and we know we can't divide by 0. So if either of these solutions results in a 0 denominator, we can discount them. In this case, both of them are fine. And in the fifth example, I have a quadratic term in the denominator, and the numerator divided by the denominator equals 1. So there's two ways I could think about this. I could think about multiplying through by that denominator, or I could just say, well, one thing divided by another equals 1, so those two expressions must be equal to each other. And then I can subtract 20 from both sides and hopefully factorise. 14 is 7 times 2, 7 take 2 is 5, so plus 7 take 2, giving two solutions of -7 or 2. And again, I just need to check to make sure that both of these solutions work with my denominator. So -7 gives 49, take 35 plus 6, that's not 0, and 4 plus 10 plus 6 is also not 0, so both of these solutions are fine. I'm going to work through 4 more examples, all involving algebraic fractions. If you manage to solve the first 5 examples on your own with no difficulty, then you may like to pause the video now and try these for yourself first. But if you had some difficulties following the previous examples or arriving at the correct solutions yourself, you probably should stop the video and go and try some similar questions before moving on to these more advanced types. So in each case, we're working with fractions and I want to look for common denominators. The first example already has a common denominator except this one term in the middle. So I'm going to replace the 1 with x takes 7 over x takes 7, and now I've got common denominators. So I can equate the numerator, and it results in a simple linear expression. Remember, each time we need to make sure that our solution is valid. So x equals 7 would produce a 0 denominator here, but our x is -3, so that's fine. In the second example, I'm going to achieve a common denominator by multiplying the two denominators together. And then this is sometimes known as cross-multiplying, because I've multiplied the 3 by the x take 8. To get the first numerator, I need to multiply x by x take 8. And to get the second numerator, it's 3x take 10. Now my denominators are equal, so I can equate my numerators, and at the same time I'll expand so I can collect like terms. And now we have a quadratic, so subtracting 3x from both sides and adding 10 to both sides, and then we'll see if we can factorise the result. 10 times 1 is 10, but I need -10 plus -1 to equal -11, and that's fine because -10 times -1 is +10. So my two solutions are 10 and 1. And just checking back to the original equation, the only value of x which wouldn't be valid would be 8, so 10 and 1 are fine. Just 2 more examples to round up the lesson. Remember, each time we're looking for common denominators and we're seeing if we can simplify to solve the equations. So in this example number 8, our two denominators are the same, so it's just a case of writing the other two terms with that denominator and then equating the numerators, and I'll expand brackets at the same time. Now, be careful here because we're subtracting, so this is take 5x plus 5 when we expand, and now I'll gather the terms onto the left because it's a quadratic. So we've got x squared take 2x, over this side we've got x take 5x, so I'm going to add 4x to both sides, and then take 2 plus 5, I need to subtract 3 from both sides, and then to factorise 1 and 3 plus 3 take 1, so my two solutions are 1 and negative 3. But here is an example where one of the solutions is invalid. X equals 1 would result in a 0 denominator. So we can discount x equals 1, not valid with original equation, and therefore the only solution is x equals negative 3. And finally we have a quadratic denominator, but hopefully you recognise that x squared take 9 is the difference of two squares and can be written as x plus 3, x take 3. And so I need to multiply x plus 1 by x plus 3, and then the 1 means x plus 3, x take 3 over itself. So now I'll equate the numerators and expand the brackets, and just again be careful because it's subtract here, so that's plus 9. So actually the x squareds cancel and we're left with a linear expression. So I'll subtract 4x from both sides, and x is 12 is our only solution here.